Welcome. Let's solve Leetcode 1639, number of ways to form a target string given a dictionary. Okay. Um, let's make this bigger so it's easier to read. You're given a list of strings of the same length words and a string target. So all the words they give us are all the same length. Your task is to form target using the given words under the following rules. Target should be formed from left to right. Okay. To form the ith character 0 index of target, you can choose the kth character of the jth string in words if target I equals words j, k. Once you use the kth character of the jth string of words, you can no longer use the x character of any string in words where x is less than or equal to k. In other words, all characters to the left of or at index k become unusable for every string. Repeat the process until you form the string target. And return the number of ways to form target from words. Since the answer may be too large, return it modulo 10 to the 9th plus 7. Okay, so let's go over this first example. So for these first 4 ways, remember we want to form this target ABA using these 3 words. So for these first 4 ways that they show us, they use the A from the first word. And for these first 2 here, they use the A from the last word. And then we have an option of choosing either the first B or the second B. So on here, they use the B from the first index. And on this second way, they use the B from the second index. For these second 2 examples, again, they use the A from the first word. And then again, they use for this part, for the B's, they use the first and second index. But then they go back to the first word for the A. They close it off. So they bounce between these 2 words. A from the first, B from the A from the first word, and B from the second word at index 1 or index 2, and then they close it off with this last A from the first word. And then here for this, the last 2 ways, they start off with the A's from here, from the last word, A and A. And then notice here that they start off at index 1. So there's only 3 spaces left. That means they have to use the B at index 2. And then now they have 2 options, or we have 2 options for closing it off. We can close the A off with this word, or close the A off with, this letter, or the A from this last word, or this A from this first word. And that gives us a grand total of 6. Okay, the other example is very similar to this, so I think that's enough for us to get started. So let's do that. What we will be using is recursion and a counting technique to help us find all the answers. Okay, so I have an example here that I think will illustrate the approach. Okay, so let's do something here. So we want to match this target with these out of these words here, and we want to know the number of ways. So let's first figure out how many A's do we have available for this first index. So that's what we'll do. How many options, or let me see, how many options match at index 0 of target? Well, that's 2. We have let me just put the index here, it's fine. Or this A. So this is A. How many A's do we have that match here for the target? And that's 2. So then fine, then we move on. So once we match, what does that mean? Well, we move on for, what does moving on mean? It means we increment the index for the target and increment the index for the words. We do both of them. We increment both indices. So now we're at index 1. Okay, so let's write that down. So now we want to match this B, but it's not really important what this B is. It's more important what the target is. So but nevertheless, that's ultimately what we're matching. So now how many options match at index 1 of target? Only one. We only have one option. So that goes one here. All right. Now that we match, we increment the word index and the target index. So again, we want to match this A here. And how many options do we have that match at index 2 of targets? So how many availability options do we have? So we have 1A here and 1A here, so we have 2. And that just comes down to a combinatorial problem. So we just multiply the number of options. And so the answer is 4. Okay, so I hope that makes sense. What we want to do is we want to multiply the number of options at every index that we're concerned with. Okay. Now, let's go to example 2. I'm going to make this a little bit different here. I'm going to put an A here and maybe put a, doesn't matter, I'll put a Z here, it doesn't matter. Okay, so now we want to do two things. So remember, we understand now if we match, we want to match this A and this A. We know that. We say, okay, we want to match this A here and this A here. Then we check how many options we have. This would be index 0, right? So the word index is 0, and the target index is 0. That's what we have here. And we know how to do that. We do it this way. We count the number of options. But there's also some other branching or another approach that will also give us answers, give us some more results. Suppose we say, no, we don't want to match there. We want to try matching over here. So we want to delay where we match the target. So what happened here? In this case, we said, okay, this is going to be a different way. We need to, now the word index is at 1 now, right? Word index is at 1, but we're still at target index 0. So that's the difference in the problem. So either we try to match at the current index, so we try to match here. If we do that, we need to go with this approach, where we count the number of options, and then we multiply that times the later results. Or we increment the word index and the target index stays the same. And it moves on to another problem. So let's write that down. So we have two options, or two main methods for counting. We count at current word index. So what does that mean? So we take the number of options times, then this is the recursive call. Then we say, okay, times the word index times the next word index times the count of next word index and next target index. So I hope that made sense here. Like for this first example, remember when the example was like this, we said, okay, we count the A's here at 0 and the A's for both of the words. And then we said, okay, that was 2. And then we moved on. And when we move on, what does that mean? We increment. Now we're not looking at this first index anymore. We're not looking at it anymore. We only care about what's going on in here. And the same thing over here. So we incremented the index for the word and the index for the target. But for this new example we're going over, there's another approach we need to consider. We also need to consider, well, let's delay the match. Let's not match here at 0. Let's try matching over here. So what does that mean? See, the other approach for this one is going to be, well, what happened here? We incremented the index for the word. So we increment So we use the next word index and current target index. So remember, when we delay matching the word here, the letter from the word, we're still stuck on this target index of 0, but we've incremented the word index to 1. So I hope that makes sense. So we use the next word index and the current target index. That's one type of approach we need to account for. And this is the other one. So the number of this was the number of options times whatever happens next down the road. And that's what we did here. Remember that? So we said, okay, how many A's were at the first index? Then whatever happens down the road, that's right here. But then there's also another approach where we delay matching the target and the word, and we increment the word index, but we do not increment the target index. And that's what's going on here. Okay, and that's basically it during the recursion. Maybe it'll make sense as I code it up. Okay, so let's get started. So one of the first things I want to do is get this, they tell us to return the result modulo this value here. So let's get that out of the way. So let's set up that modulo or modulus. MOD equals 10 to the 9th plus 7. Okay. And then let's find the length of the word and length of the target. So let's do that. So the length of the word is basically the same for all of them as they tell us. What do they tell us here? This says yes, here you're given a list of strings of same length words. So we know all the words are the same length, so we can just take any one of them. Okay, and then the length of target is going to be length of t. Okay, and now one important thing is we have this number of options. So remember, for the first example, we wanted to know how many A's were available. So that means at every index we want to know the number of characters. So we need to know. So at every index, we need to know the number of characters. So essentially, we'd want to say, okay, we'd have a frequencies, and it would say at index 0 for A, it should be 2, right? Because at index 0, we have 2 A's available. And at index 1, we want to know how many B's we'd have available, and that would be 1. And index 2, and then we do the same thing kind of like this here. So that's what we want to do. We want to form counts that are going to help us solve our answer or find our answer. So let's figure out how to do this. So I think we can do that pretty easily. So let's use a default dict for this. And notice how it's has 2 layers. So I'm going to use a default dict of a default dict with an integer as the value. So let's say frequencies equals default dict lambda of default dict of an int. Okay, great. So then let's say for word in word, we're going to loop through all the words, and we're going to say for what we can do is, I think we can do this here. For I in range of, we know the length of the word right here, so we're going to use this m here. And then we'll say, okay, frequencies at index I, the word at index I, sorry, the letter at index I, then we'll just increment it. Okay, and then let's print it out so we can get a look at it. So for k, v, in frequencies dot items print k, v, and let's return something so we don't get an error. So I just want us to see what it looks like. Okay, great. So at index 0, we have 1 A available. Remember, So at index 0, there's only one A, so that makes sense. At index 0, and then so look at index 0 for all of them. So at index 0 there's a B, and index 0 there's a C. So we have all of this. At index 1 we have a C here, a B, and an A. So we have the same type of result. 2, at index 2 we have a C, a B, and a C. So we should have 2 C's and a B, okay. And 3, we have an A here, so 2 A's and a B. Okay, great. So that's what we have. Okay, great. So now let's figure out how to solve this. So as I mentioned earlier, we're going to use recursion. So recursion. So define, and we'll just call this maybe I can't think of a good thing. Let me see. I'll just call it F. For function, I can't think of a good name. Now, what do these represent? This is represents the word index and the target index. Okay. So, the base case. Let's think of the base case. So how do we know when we're done? So I know for sure if the target index equals what? Well, if it's the end of the word, we can stop. If we've reached the end of the word, that's good. That means we know that we can return 1. That means that's one way of reaching the end. So this is one way. Also, we know if we've reached the end of the word, well, if we reach the end of the word, that means we return 0 because we haven't reached the end of the target. Remember, we're more concerned with the end of the target. So in this case, we return 0. And I will be adding an optimization that will improve the time complexity at the end of the problem. And let's get this out of the way for the moment. What else? What else? Now remember, previously we used the counts and then we multiply times the other results that we yet to calculate. So we're going to do that here. We're going to say, okay, let's try. We're going to say the count equals frequencies of the word index. That's where we're at. And we're concerned with what? Which letter are we concerned with? We're concerned with the letter at the target index. That's what we want. So we don't really care where we are in the word. We want to match the letter of the target. So okay, so then how do we get that? We say, okay, that's going to be T of Ti. Okay, it's going to be that. And then, so where we're at now, then we move on to the next recursion. So the next recursion would be what? So we say, okay, F of what? So remember, we have two options. We can try to match here. If we match here, what do we do? Remember, if we match here, we multiply 2 or whatever the count is, then we increment both of we increment the target and the word index. So it would be count times, now we increment the word index because we matched already, and then we increment the target index. This is one approach. But the other approach was to not match here and try to match later on. So in this other example, or the other type of count we need to include, remember we delay incrementing the index for the target, but we forward the word index. So that's what we do here. So this was basically the first example that I did here. Remember where we matched A and A for the once you match A and A here for the target and the word, then you kind of ignore them and then you move on to the next one, because remember, we cannot use them anymore. We have to move on. We move forward. So we increment the word index and the target index. So that's what we've done here. But remember though, sometimes the word is longer. So we had something like AABA, and in, so the point was, instead of matching here, we'll try to match later. We'll try to match there. So that's what we're doing here. We're incrementing the word index, but the target index stays the same. So that's why we have, that's what's going on here. And we just return that. Now, well, let me just run it and have two things I need to go over or mention to you. So we just return, well, sorry, one thing we need to do is we need to modulus this by the mod. And then we can just return this. Return, what is it? F of 0, 0. So let me just call it, maybe DP is a better, like for dynamic programming, maybe that's better. Well, I'll just leave it as F, but that's what I should have called it. Let's run it. So this might be I'm going to submit it now, but I'm going to give you 2 pointers. It will be time limit exceeded, and the next it'll be too slow, or it'll be slow. So this will be a time limit exceeded. Because remember, for most recursive calls, we'll want to cache the results. So what we do is we'll add caching here, because there'll be some repetitive calls. So we want to avoid that, and then we'll submit this, and then this will pass just fine. And now I have one optimization that will make our answer very, very fast. Did I submit it yet? Okay, so this works fine as it is. So I want to make this point though, like, so either we match at the current location and then we move on, but then we use a count times it, or we try moving it on later, and we increment the word but not the target. So now going back up to this example here, so remember we can try matching here. Sorry, go to the top. So we can try matching here, or we can delay. Now the same thing though, couldn't we try matching here? Try matching here and here. Or what? Like before though, we could delay, right? We can move this over. But now notice we have a problem here. We have a problem here because we've gone past the bounds, meaning like, even if this did match, even if it did match, we wouldn't be able to match the other letters. So do you see there's a point to which, remember when we delay the match, it's not going to work anymore. So my point is, if there's not enough letters remaining, then it doesn't make any point to delay. So how do we figure out the number of letters remaining? So that's easy enough. So we say, instead of this here, I'm going to modify that. If I say something like, so we know the total number of letters. We know this is the total number of letters, and this is where we're at. Suppose this is like 2. If this is less than the number of letters that we need for the target, then we can stop. So the number of letters I need for the target are the total number of letters, which is n here, minus the number of letters that we're at. And if we're here, we return 0. So again, that's an enhancement that'll make and it makes sense, right? Because if we can't, like I mentioned here, like skipping over here is okay, but if we skip too far, it doesn't make sense because we don't have enough letters to match the target. So we should just stop. Okay, and that's it. So I hope you found this helpful. I think for me, I actually like this problem. If you found this video helpful or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.